All right, here we go. So we're gonna multiply and divide complex numbers.
Hey, Coach. By the way, I don't know if I can still give it into you for any credit, but I did do the box project.
We'll talk about it later. We'll talk about it later. All right, so we're gonna multiply and divide two complex numbers. So in polar form. So just to be clear, you don't have to write this, but let's say we have some complex number in polar form. We'll call it number z. And remember, it has a radius of maybe like 2 or something. I'm just making this up, so it's like a little review. So maybe we had a radius of 2, and then we had cosine of 45 degrees plus our imaginary unit, sine of the same angle. And I think my red pen has seen its last day. This is z.
You look like a fisherman.
So, I am hot.
All right. So this would be a complex number in polar form. We've got our r value here, which is 2, and then we have our angle measure, which we put in here. This is what we were working on last class, all right? All right, you come in late and you disrupt everybody once we just got quiet. All right. Everybody on board with this complex number in polar form.
Yeah.
What we're going to do is take two of these, and it's just a few formulas. It's very straightforward. But say you had some other number w, we're going to multiply the two of these. We're going to divide the two of these. And then there's this De Moivre's theorem, which is like the power rule, which we'll do. It's not difficult stuff at all right? So we're going to get started by multiplying these two polar numbers. We have a number z, which has the following values. And then we also have w, which is a different point. We've got formulas here that shows us how we multiply and divide. All right, the printer needs new ink. So let me know if you can't see something and we'll write it out again or whatever, all right? So we're going to multiply z with w. The first thing you do when you multiply is you multiply the two r values. So I will take 4 and I'll multiply it by 2.
Wait. It's cut off on the left a little bit.
Oh, my picture, got you. All right, so that's r from z times the r value from w. Everybody okay?
Yes.
Okay, then I've got my cosine. And I'll take the two angles. When we multiply, we add the two angles. So I've got 35.
115.
Yep, it's going to come out to be 115. You can go ahead and write that if you want. I'll take the angle from z and add it to the angle from w. I'll do the same thing for sine. Don't forget your imaginary unit. Sine of first angle plus the second one. And then you just simplify this. What's 4 times 2?
8. Unless.
Good job.
Okay, listen. It sounds like you're being sarcastic. I'm sorry.
Good job.
It did sound sarcastic, but we're going to keep it moving. It did sound, I can't lie, it sound. Same thing happens to me, Cole, so don't take it personally. 35 plus 80.
115.
115.
Good job. You know addition, wow.
And the other angle will also be 115. And just like that, we multiply two complex numbers in polar form.
Wow. Wait, that's our answer?
Yes.
I'm not gonna lie, I kind of forgot how to do some of the things we did the last thing we did. Imagine.
So tell them.
This doesn't look
Imagine
like an
being
answer, but I
dumb.
don't trust it.
That's how we have our answers on the other section.
Yeah, it's the same thing. I don't know why people would be so dramatic. It's literally the same form. I'm with you with that. All right, so let's divide the two. Any questions on multiplying? You multiply the r's and you add the angles. When you divide the r's and you subtract the two angles. Okay, so we got the same two points. This time I'll do z's r divided by w's r. So we got 4 divided by 2. I'll take my two angles, cosines first, and this time I'll do
-45.
35 minus 80. And I'll do the same thing for the sine. My imaginary unit sine, 35 minus 80.
I like teenager Karens.
Negative 45, I think. Yeah. What's 4 divided by 2?
2.
And then as we just discussed up here, this is negative 45 degrees. I sine of the same value, negative 45. And this is my answer. I can simplify it with the angles being negative. If I think about the even-odd identities, cosine's even. Anybody remember what that would tell me to do with this?
It'll be positive.
I would just leave it as positive because with cosine, it doesn't matter that the angle's negative. I'll get the same exact value. So cosine being an even function, I can just write it as cosine of 45 degrees. And this is just even-odd identities. Sine, since it's odd, what would I do with sine with this negative angle?
So would it stay negative?
The actual function would be negative. So I would make this positive 45, and I would just make this negative sine, and I would get the right exact value. So if this becomes negative, I would actually be subtracting sine of 45 degrees. And this is just from the even-odd identities. All right, we got any questions?
No.
Okay, I want you guys to take a second and see if you can multiply and divide the two complex numbers in polar form below. Take a second, see if you can do it. Yeah, it's different numbers, but it's applied the same.
I'm sorry, repeat. We're doing the next one, right?
Yeah.
Okay.
They don't have the big peaches. But with the oranges part, you gotta like pop the seal a little bit. You gotta drink the juice.
Yeah, I agree with that. They push really bad. I mean, I don't hate it objectively, but I just think it's better that it's
Or you can put it in blender and then it just slushy.
Oh, that's true. I don't like that though. I don't like peach, but I don't like blending. I don't like it blended juice.
It's all smooth. Because when you froze it, like when you freeze it, you put it in the blender. Wait,
Does it taste good?
yeah. It just tastes
How would I use even-odd identities to simplify this?
You might need to look them up, but cosine's even, so the negative doesn't matter with the angle. Sine's odd, so you just put the negative in front of the function.
Okay, so if it's even for cosine, it's always positive.
I can use the oven really well.
And
That's
if
my
it's
special talent.
odd for sine, is sine always positive if
I
it's
have a
odd?
cinnamon.
It's an odd function, so that means that if you have a negative angle, you just make the function negative.
Alright.
It'll make more sense if you look at your notes. Do you have your notes on the even-odd identity? So you might need to go on Schoology and look at them, and then it'll make more
Is
sense.
this from the previous unit?
Yeah, this is from 5.1.
5.1? Thank you. Also, thank you. Oh,
Huh?
thank you for plugging in 60% credit for that.
I put a timer.
Um,
And it.
just leave it.
It's not good.
Is that really wake you up? You know, the decimal?
Nah, we don't like decimals.
But
Like that, we like exact values and
Alarm on your
fractions.
phone every time. That's what makes me fall asleep.
that's what I do. I have a 725, a 725, a 730, and 735.
No, I'm talking about when you're really.
They're requiring freshmen.
Yeah, next time. I burnt it. I still need it though. The glaze is good.
Oh, yeah.
Choose first signature.
It's been here since he gave it to me.
That's like black really.
Hey, the bottle still work?
Yeah, it's an apartment.
No, wait. He gave it to you
That's
this
how,
week.
actually.
Yeah.
All right, questions on 1? So sometimes we need to do this. Obviously, 400 is bigger than 360, so we need a coterminal angle that's less than 360. What would I do to this 400? Subtract what?
Find coterminal for 360.
Yeah, just subtract 360.
Oh, we're supposed to find the coterminal.
This is like simplifying these.
Okay. Yeah, me too.
So I think the difference is 40, and then I sine 40 degrees. Cole, don't leave that back there.
I will move it back up.
So this would be my simplified answer.
That's what he does.
And man, it took me 45 minutes to sweep this room. If I see one on the ground, I'm getting you every time my room needs sweeping for the next 365 days, Cole.
We don't have any seats back here.
Oh, okay. Why you need a trash can?
Why do you need two trash bins?
Like this one's overflowing.
Yeah,
It's useful.
So you got the second one. Huh?
so we gotta change it.
But like, who's gonna, like, you wouldn't
All
have
right.
to walk all the way down.
Questions on this one?
You come with the cart.
Yeah, he clearly didn't pick it up for the last 3 days though, did he?
Yeah, so I don't think,
So that's why I got 2.
Maybe not going.
because I have to get the whole.
Do not be coming with the cars.
One day he came in all four of my, all four of them.
All right, we have questions on this one?
No.
Okay, so sorry I ran out of room. You divide the r's and you subtract the angles. My next line is a little bit cleaner. You'd leave it as 3/4.
Yes.
130 minus 270, negative 140. Everybody okay with that?
Yes.
And then if I apply even odd identities, what happens with cosine of negative 140?
Wait.
Just cosine of 140.
Yeah.
I would get the same exact value because it's even.
Cosine
It's an even function, so I would just do cosine of 140.
and you do
What about sine?
you do minus I, and then positive 140, right?
Yeah, so I would, to make this angle positive for an odd function, which is what sine is, I would just do minus sine of positive 140. So when I do that, it makes this whole second part negative. So I'm going to go ahead and just do minus I sine of 140.
Maybe,
No, that would, because she says the N word like every other.
maybe her music would be better.
Okay, that was the dividing two complex numbers. Guys have any questions?
I can't imagine, now you're trying to.
So if you were given these in radian form, you might would need a common denominator just to be able to add or subtract it.
Yeah.
We should be able to find common denominators, all right? So let me know if you get some on homework and it's common, it's a radian measure, you need a common denominator. Let me know if you can't convert those, all right? All right, so
No heads
as you see right here, we have this complex number in polar form, and it's raised to the 4th degree, which might be tough to see, so I'll write it up here. This is to the 4th power. So now, if I wanted to multiply this like 4 times, that would be pretty tedious. I would have to do this like 4 different times, which could take me a very long time. We have what's called the Moore's theorem, which is like a shortcut to figure out what the polar form of this would be if we raise it to a certain power. This is pretty straightforward. Your power represents n. So in this case, if we raise it to the 4th power, Wherever I see n, I'll put it into the formula. I'll raise my radian measure to the fourth power. I'll multiply my angles by 4, and then I've just used the Morse theorem to figure out what this number would be to the fourth power. All right? Important part right here is this has to be in polar form. So it's got to be in polar form. Just remember that. All right, so let's do it.
This first one's given to us in polar, but the second one I have to fix.
Yeah, we got to convert. We got to convert it. All right, so this is already in polar form, so I'm going to do 2 to the nth power. N is 4. Let me just write that. So I'll do 2 to the fourth power. Then inside, I start off with the cosine of 15, but I'm going to multiply 15 by what?
4.
So 4, which would be 60. 4 times 15. You can go ahead and write 60 if you want. Plus I sine of the same situation. 4 times 15. What is 4 to the fourth power? 2, 4, 8. 8 times 2? 16. 2 to the fourth power is 16.
Wait, did you say 2 to the fourth power or 4 to the fourth?
He said 4 to the
You
fourth.
said 4 to the fourth power, but you were looking at the paper, you know.
Oh, I'm sorry. I meant 2 to the fourth power. My apologies. 16. 4 times 15, we said was 60.
60.
So the other angle will also be 60. All right, and we just applied the Morse theorem. If I multiplied all this out, this is what I would get. I don't need to do any even-odd identities. I don't need to do coterminal angles. This is what I get. Everybody okay with this? What kind of form is this? Polar or rectangular? Why you say rectangular?
Wait, it's polar, right?
It's polar. How'd you know it's polar?
I just looked at the last.
Okay. What do you notice?
Angles.
Yeah, it's got angle measures in it. Does polar have cosine and sine in it?
No.
Yeah, it does.
Oh, it does?
It does. Cosine of an angle, sine of an angle. That's polar.
Rectangular has radians, right?
Rectangular just has numbers.
Oh, right, okay.
Just numbers. Okay? So polar has an R value. It's got cosine and sine. It's got angle measures. Rectangular form is just a complex number. How do we want to write this in? What does our answer need to be in?
Rectangular.
Rectangular, also known as standard form. So we need to convert this to rectangular form for our final answer. Anybody remember how we do that? It was the easier. It was only like 1 or 2 steps.
You multiply it by the x and y coordinate.
The x and y coordinates. So yes, the x coordinate is cosine. So basically, I just need these exact values. And then I'll multiply by 16.
Yeah.
It is. So on my unit circle, if I had one, I would show you. But you go to 60 degrees. Cosine of 60 is the x coordinate. At 60 degrees, cosine is 1/2. So I'm going to replace it with this exact value. At 60 degrees, sine would be
Root 3 over 2.
root 3 over 2. So I'll replace it with this exact value.
Oh.
I'll distribute the 16. Yep, my first term would be just 8 because 16 divided by 2 is 8. And over here I would get 16 divided by 2 again, which will be 8 root 3, and then I need my imaginary unit.
Oh, you did that.
And you could probably put it at the front. I just like to put mine at the back. In the previous class, some people were getting these wrong because they would do the square root of 3 and their I would be inside the radical. So just make sure you hit your arrow right and you leave the radical and then you put your I like outside of it if that's what you put. You could probably do 8I root 3. That way you won't have to worry about it. All right, anybody got questions?
No.
This is standard form, also known as rectangular form. Notice there's no cosine or sine in it. Notice that there's no angle measure in it. It's only a real number and a complex number. All right, let's kind of summarize everything we've been doing in this lesson and this last problem to finish up. All right. So we want to do the Morris theorem again. In order to use this, we need this complex number in what form? Standard or polar?
Oh my god. That scared me.
Thank goodness it's
She said,
hollow.
love you too, homie hopper.
Yeah, it is.
That box is about to fall off.
It's still okay.
No, no, no.
Wait, the thing is
Really
about to
fun.
fall off.
It's
Maybe you
very
should like put it down before it knocks you out.
I'll be okay.
It's just fall off.
And if it knocks me out, I'll go home and
It
get,
could be knocked out, so you-
Yeah, you won't go home.
I'll get-
We would
I'll
have
get
to
leave.
pick you up, drag you to the nurse office.
I'm saying I'll get to be home for a few weeks until I recover. All right. Okay, so did we answer the question? What form is this in?
That, isn't that the
That's,
rectangular?
It is rectangular. How'd you know it was rectangular? What?
Because it's
What don't you see?
convert to polar,
it's
so
got numbers.
Okay. It's got numbers. Do you see a sine or a cosine?
No,
no,
Do you see an angle measure?
no.
no,
Do you see a R value out in front?
no.
So this isn't polar form. This is in rectangular form. In order to use this formula, it needs to be in what form?
Polar,
Polar. So I need to convert it, don't I?
yes.
So you don't worry about this power 6 just yet. We'll do that in a second. Let's convert this rectangular complex number into polar form. Anybody remember what we did first when we did this earlier?
Didn't we like do the root, or was that the
Yeah.
Root, of x squared plus y squared.
What do I do before I find the hypotenuse?
you draw the
I draw the point and I draw the triangle.
Oh,
So let's plot this point. How do I move first?
you go up.
why do we have to plot it?
Right to.
I guess you don't. I mean, you need to find the radius and you need to figure out what angle this is. And when you plot it, it's just visually easier to figure that
Okay,
stuff
'cause I
out.
haven't been doing that
Where
at
would
all.
2 be?
Like you need to know what quadrant it's in. Maybe you
Yeah.
can get it, but the average, it just makes it easier.
Okay,
Kind of like reference angles.
so
You don't
it's not
have.
necessary.
Not if you know like what you're doing.
Okay,
Maybe not. All right. So back to the original question. How do I move first to plot this complex number?
Right to.
Right
the
to,
first quadrant.
and then what?
Up to.
Up to. Right to. Up to. Complex point is right there. I need to set up my situation, so I'm going to draw a reference triangle. And now, converting to polar form, I need an R value and I need to find the angle. R is the hypotenuse, right?
Yes.
Any ideas as to what this is? It's a 45, 45, 90 triangle.
4, wait, 90, so.
It's 2 or 2.
Yeah, 2 root 2. You multiply the leg by root 2. Good job.
Right.
If
yeah.
that doesn't make sense,
That's how 45, 45, 90 triangles work, I forgot.
that's okay. We just use Pythagorean theorem.
Yeah.
2 squared plus 2 squared.
And then you get,
That equals
it equals A, and there's, through A is not the thing, so then you have to simplify it, 4 times 2, and then
And
you
you
take
have
2 out,
to
and
take
it's
the
2
2
root 2.
out, and then you get
Yeah,
down
okay.
to.
All right. Everybody okay? How we got here?
Yes. Yes.
Questions? All right. All right. So we just found R. R is going to go in right here. What else do we need to convert it to polar form?
Cosine and sine.
Cosine and sine. What about cosine and sine? We need to know
The angles.
the angle, okay?
Oh,
We already said the coordinates are the same, right?
Yeah,
What angle does that happen at?
45.
45. So without a lot of work, you know this has to be a 45-degree angle. Let's say we didn't remember that. I could figure that out by looking at cosine's ratio for this situation. Cosine is which two sides?
A over H.
Adjacent over hypotenuse. The adjacent side is 2. The hypotenuse is what?
2 root 2.
Anything cancel?
2. Just left root 2. Root 2. Root 2. Root 2. Root 2.
All right, then I say, oh, in the first quadrant, because that's where this angle is, when it's cosine's exact value, square root of 2 over 2, you say, oh, at 45. Okay, so now we got our R value, and we got our angle, theta. So now we can write this as a complex number in polar form. Everybody okay with what we got?
Yes.
All right, so let's write it in polar form. R is 2 root 2. Cosine of the angle we said was 45 degrees plus my imaginary unit, and then sine of the same angle of 45 degrees. So this is polar form. This is my R. This is my angle. Everybody okay?
Yes.
I'm tight on space, but we go back to like our problem, and this is to what power?
2. Wait, 6.
6. So I raise this to the 6th power. And then we get to do the formula. All right, everybody still okay? So to use this formula, what is n? The power. What's the power?
6.
So I've got 2 root 2 to the 6th power times cosine of what times 45? 6
Yeah.
times 45 plus I sine of the same situation. 6 times 45. Let's take a second and see if we can see what this comes out to be. We, for whatever reason, several of us still kind of struggle with this. So take a second, let's see if we can figure out what this is. Or at least see if we can put it in our calculator correctly. I think you did times. And you need to use parentheses around that. Value.
Demois, is she French?
I have no idea.
I think he's French.
Is she? Is it
It might be.
Not quite. You got to put that 2 root 2 in parentheses.
Yeah. I don't know if he's French or if he's.
Anybody else got it?
He's French.
What you get? Oh, I thought you were answering my question. My bad.
He was just,
What do you want me to answer?
he was just
Huh?
looking at his calculator, and you was just like, what did he get?
Well, he said something, and God forbid
never
I
said
check.
anything.
God forbid I check to see if you know what you're doing. What'd you get?
I've 512 is what I got, I mean.
512 is it? What'd you get?
512.
512. Okay, 512 is it. I'm gonna do it by hand. All right, but you get 512. So some problems I see is people put it in their calculator and they don't do the parentheses, and it just does root 2 to the 6th power.
Oh, you got parentheses.
Then you get 16, that's not right.
That's not right. Some people do that, and that's not it. Some people do 2 to the 6th power times root 2. That's not it either. You need a parentheses if you're going to do it in your calculator. Right? And you get 512. Okay, does that make sense?
Yes.
In a nutshell, what we do is 2 to the 6th power times root 2 to the 6th power, which is 512. So if you did it by hand, this is how you would do it. Everybody will feel like they know what they're doing.
Yes.
So hopefully I don't see this mistake as often. Okay, so this comes out to be 512. Everybody okay with that? And then I got cosine of, what is 6 times 45? 270, nice. That's the value for both of my angles. And that is the complex number in polar form after I raise it to the 6th power. Is that what I want to write my final answer as, though?
No.
What form do I want it in?
Standard.
What form is this?
Polar.
How do you know it's polar?
Angles and cosine.
Angles and cosines. So, how do I convert it to polar? I mean, to rectangular form.
Distribute to the exact values of cosine and sine of 270.
Okay, so let's find these exact values.
Negative 1, 0.
Yeah, just 0, -1.
Wait, that's 0?
Casual day sport.
Yeah, 0.
Because 270 is right here. The coordinates are x is 0, y is -1. So cosine of 270 is 0. Sine of 270 is -1. This is just looking at my unit circle or knowing my unit circle. So what I got is
0 plus negative 512.
512. Cosine was 0 plus -1i. I would have just wrote -i, but some of us need to see it. Then I'll distribute 512. As London said, something times 0 is just 0. And then 512 times -i. So you can leave your answer like this, or you can go ahead and just write it as an imaginary number, because you don't really need the 0.
0 minus.
All right, so this is my answer in polar. We just converted it to standard form. You guys have any questions?
Nope.
All right, so there's not a new assignment. There's only the one that we were working on, but now you should be able to do all the problems. All right, I started grading your quizzes. I'm hoping to get those back. I'm hoping to get your quizzes back before the class is over. And what I'll do is I'll let you retake the quiz if you want to get a higher score, but I'm not like going to try to stop people from just, let me just try and guess it again and now I got to grade it again. If you retake it, I'm going to throw the first score away, and whatever you get on the second attempt is what your score will be. All right, so if you need to retake it, make sure you know what you're doing. Don't just grab it and hope and cross your fingers. Look at your first one, see what went wrong, make sure you understand what you missed, and then between now and next Tuesday, Wednesday, we can do a retake, and your score, it will be your new score. So if you made a 15 on the first one, and the second one you make a 10, you're getting a 10. Right? Don't waste anybody's time.
You gotta do better than the last time.
That's unless you feel like if you made a 35 out of 40, and it's I want to get a 40, make sure you know what you're doing. Don't waste your time. Don't waste my time. Make sure you know what you're doing. All right. All right. Anybody need test corrections? I'm getting tired of saying that. We're not finished. All right. We're getting finished today.
Oh, yeah, I do need.
My phone was in my car, go grab it.
I end up in the car.
Cause I brought it and then,
How you brought it? Why you brought it? You're not supposed to bring it. You already know.
well, I still brought it because I'm trying to get some, at least I did it.
Yeah, you're supposed to be doing it in class.
Oh, well, I finished.
You finished it?
Yeah,
You left it in your car?
yeah, I finished it at home.
Is your name Cole Lawson?
Please.
The test correction?
No.
He's talking about his box project.
The box project,
Oh, the project that was due 2 weeks ago?
1 week ago, but yeah.
It was not 1 week
it was
ago,
not-
it
it
was
was
2 weeks ago.
No, last Friday, wasn't it? Well, I still
But
finished
he
it, trying to
extended,
get some
he
type of
extended
credit.
it,
So no
he
test correction?
extended it to the test day, but it's basically been 2 weeks.
It's been 2 weeks.
I'll give you a week and a half.
Well, I still did it, and I'm still trying to get some type of credit for it.
How,
Hey, a
yeah.
30.
How do I know? How do I know? Like, how do I know you did it, though, Cole? How do I know you just never
It's,
did?
no, it
You
is,
just tell me you did.
I'll go grab it from my car, it's in my car.
How I know you didn't do it like this morning?
I didn't. I'll be honest, I didn't finish it late, I finished it like, what was it, what's today, Thursday?
It should be like 1 point off.
Finish it like
I finished it like Saturday, like, I think it was Saturday.
1 point off each day. All right, does anybody else need their test corrected? I'm assuming everybody else in this stack is done. You need yours, Ty?
Yeah. Well, can I go grab it from my car real quick?
Yeah, go grab from your car. It's more of a donation instead of like actual, because it was 2 weeks ago.
Man, you're right, you're right. Hey, a 30's better than a 0. You have,
Where are the,
It ain't how it works though, but I know what you mean. Huh?
the test?
Oh, I got it. All right, anybody I missed need theirs? Okay, let me put these up and let me get them and then I'll- Okay, it's up here. Which one you?
Corrections.
Somebody teach you a paper quiz, we came in one day for the shoot, how we worked on those problems. Did you take it? I just had it raised, yeah, so. Okay, yeah, that's what that is. Try to grade them now.
That's okay.